talk about gas pressure, which just means that gas is like pushing on something. Okay, we're going to do this in 2 videos. This first video is pretty short, and it's just a basic introduction to gas pressure. So if you don't know anything about it, no big deal. In about 5 minutes, you'll learn everything you need. And then in the next video, we're going to talk about atmospheric pressure, which is like how much the air outside us in the environment pushes on us. And then we're going to talk about ways that
the air outside the environment pushes on us. He just told you it has pressure. This is a basic video for basic brains. Sorry, you don't have to like it.
Can measure gas pressure. Okay? So, even if you don't think you know a lot about gas pressure, you really do. Right? Because you deal with it a lot in everyday life. If I say gas pressure, like, what are the things that come to mind? A lot of people say, like, a soda bottle. You know, a soda bottle has gas pressure. Like, the gas inside pushes against the bottle.
Pushes against the bottle?
Makes it really stiff. And then you open the cap, and all the gas comes out, and then there's not as much pressure in there. Or an aerosol can is something that we know has a lot of gas pressure in there. There's a lot of gas stuffed in there. Those things. Particularly, though, when people are talking about gas pressure or air pressure, one of the most common things that comes to mind is a tire, right? Pressure is really important for a tire because the higher the pressure of a tire, that's how we talk about it, the harder a tire is. So let's use a tire to think about gas pressure and learn a little bit more about it. Okay? So I'm going to draw a tire here. Here is our big tire. Pretty brilliant, right? It's not a donut, it's a tire. Okay? So this tire is filled with air, right? Because we pump air into the tire to give it more pressure. What I want to do is I want to pretend that we can look inside this tire with like X-ray glasses. And these X-ray glasses are also super magnification glasses. So we can see the stuff that's in this tire in a way that, we couldn't with our naked eye. So let's think about the air that we're pumping into this tire to increase its pressure. Air is made up of a bunch of things. It's made up of some nitrogen, some oxygen, argon, carbon dioxide, a couple other things too, but these are the main things. And these...
Do you understand that? It's a gas. Air is a gas. You don't have to like it.
Guys are atoms and molecules. Some of them like nitrogen and oxygen are molecules that are made from more than one atom. Some things like argon are a single atom, just a single atom of argon. But all this stuff is what makes up air. So if we could magnify this millions and billions of times...
Those are all gases. You don't have to like it.
Inside the tire, we would see all of these different molecules inside here. But you know what? I'm lazy, right? I don't want to draw all of these different molecules inside the tire because it's just a pain, okay? So what I'm going to do is I'm going to abbreviate all of these different types of both atoms and molecules by just drawing these little red round circles. And these red round circles stand for maybe either single atoms or things like carbon dioxide, which are actually 3 atoms or 2 atoms, nitrogen, 2 atoms, oxygen, whatever. I'm going to fill my tire with these tiny little circles that represent the molecules or atoms of the air in here. And we call these guys particles. Okay? It doesn't matter whether they're representing atoms or whether they're representing multi-atom molecules. They're particles. Okay? So let me fill this up with little circles that represent the particles. Okay, now in reality, there would be trillions, billions more particles of air inside this tire, but this gives you an idea. There's something here that I haven't drawn, because it's hard to draw. And that is that each one of these particles, whether they're atoms or molecules, are constantly flying around inside this tire. Okay? Here's what I want you to think about. You know how, like, when they do the lottery numbers, there's that like plastic container, and there are all those numbers inside, and they're all flying around, banging against the side of the container.
Container, 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 container. Get that in your brain. Container. Your head is a container for your brain, but you don't have a brain. What would you do with your brain if you had one? What would you do with a brain if you had one? Would you use your brain? It's a container. It's a container. Do you understand that? It's a container. This is basic chemistry, basic physics for like a 10-year-old child. And there are people with PhDs in astrophysics that don't get this. Please do not procreate.
That's exactly what I want you to think about when you think about the particles of air that are inside a tire here. They're just like those lottery balls, those lottery ping pong balls. They're banging all around on the inside of this tire. They're hitting into each other. But the most important thing is they're banging into the sides of the tire. The fact that these guys are flying around, and I'm adding these arrows to show that they're in constant movement and they're banging into the sides. Really, every single particle should have arrows showing its movement, but I'm lazy. Even if you don't think you know a lot about gas pressure, you really do, right? Showing its movement, but I'm lazy, and I don't want to have to draw these, but just imagine that all of these are flying around just like these lotto balls, okay? And so, when these guys bang against the inside of the tire, it presses. It exerts a force on that tire. And that's what keeps the tire inflated. That's what keeps it hard, is that all of these gas particles from the air banging against the inside of that tire. You know, when a lot of people learn this, they're like, there is no way that these tiny gas particles, atoms or molecules that I can't even see with my eye are banging hard enough to keep my tire really firm so that I can, drive on the road with it. But that's exactly what's happening. Your tire's full of air, and the air is banging onto the inside of that tire and is keeping it firm. Right? So that is what gas pressure is. That's how gas can press against something really hard. It can exert a pressure or a force. And if it's something like a tire...
Notice he's using air as a demonstration of gas pressure and telling you the basics of what air is contained with as a gas.
It can inflate it. The more gas we have in something, the more pressure it exerts. So something like an aerosol can has so much gas inside that's banging against the inside of that can that the can has to be made of metal.
What is a can? What is a tire? Are they containers, boys and girls? Are they containers to hold the air to create the pressure, boys and girls? Is there such a thing as atmospheric pressure, boys and girls? Listen, children, atmospheric pressure is real. Air is a gas. This is real. And in order to have pressure, atmospheric pressure, whether it's gradient or not, it has to have a container to press upon. And you can obfuscate and talk about gradient pressure all you want. I don't give a flying fuck what you talk about. But you cannot have gas pressure without a container in the first place. For gas pressure to exist in the first place, it must have a container. What came first? Pressure or gradient pressure? Bitch.
Of really strong metal in order to hold all that gas in to prevent the can from breaking, because there's so much force, there's so much pressure that comes from all the punching. And you may know this because there are lots of videos of people doing this stupid thing on YouTube. Don't do it yourself. Please don't do it yourself. But if you put an aerosol can and heat it up. Don't do this. It blows up, and it does that because the hotter it gets, the faster the gas particles move, which means the harder they pound into the sides of that aerosol can, and eventually they're moving so fast and they're punching so hard that even the metal of the aerosol can can't hold that pressure in anymore because they're punching so hard, and bam, it explodes because of that pressure. So the hotter it is, the more pressure.
We have extreme heat. We have extreme cold. Nothing's blowing up. We still have pressure. Must be a pretty fucking solid fucking container. Bitch.
Pressure a gas exerts, the more gas you have in something, the more pressure it exerts on the inside. A lot of times when we're talking about pressure, we want to be able to measure it. If we're using a tire, you can just say, oh yeah, I'll just go get a pressure gauge from a gas station and stick it on the tire, and it will tell me how much pressure is in that tire, how much force these gas particles are exerting. Okay, yeah. You could use a pressure gauge from a gas station. But I want to talk about something that it was like one of the original ways that people used to measure pressure that is still a big deal when we're learning about pressure, okay? And that's something that is called a manometer. Don't call this a manometer, right? People see this and they're like, oh, it's a manometer, like something from a cheesy 80s dating show. No, it's not a manometer. It's a manometer. And here is a very simple thing that I can do to make a device, a manometer, that measures pressure, okay? Imagine that I have a glass tube, and I bend this tube into a U shape, okay? And then I fill it with water. I get something that's called, very creatively, a U-tube, long before they had the
YouTube. You're in a tube, YouTube.
Video sharing website. You can tell that whoever named this a YouTube was very creative. And a U-tube is just this bent piece of glass with water in it. Okay? I hold the U-tube just like this, and the water levels out on both sides of the U. Okay?
The water levels out on both sides of the U. Without any gas pressure, but by itself, it levels out. Level. Meaning the exact same height on both sides. Maybe they should take a U-tube that's fucking 5 miles long and put water in it and measure both sides and see what happens. Bitch.
Now, imagine what's going to happen when I exert a little bit of pressure from gas on this side of the U-tube. I could hold it up to my mouth and blow on it, just like a straw. What's going to happen to the water in this U-tube when I blow in here? Well, when I blow in here, the gas that I'm blowing is going to press. It's going to go around this glass tube, and it's going to press here on the surface of the water. And that's going to cause this side of the water to go down, and this side of the water to go up, right? One of them is going to go down while the other goes up. And when I blow into the side of this U-tube, I'm going to get something that looks like this, where now the water is low on one side and is higher on the other, because of that pressure that the gas I'm blowing in exerts on the water and pushes it down, right? Just the way that air pushes on the inside of a tire, and it exerts a pressing and it exerts a force on it, okay? So I can use a U-tube like this to measure the pressure of something, say, in like my tire. And what I do is I take my tire and I connect my U-tube to it, and I open up the tire so that then the air could press in here. And what would end up happening, just as with what happens when I press into it, is that the air from the tire, let me just draw this so it's clear what's going on here. I've taken the tire and I've opened it up so now the gas can flow into the U-tube. And what would happen is it presses now not just on the inside of the tire, but it presses on this water forces it down, and forces the water up here. Okay? And now there's a difference in height between one side of the U-tube and the other. And what I can do is I can actually take a ruler and I can measure this distance from the bottom water to the top water, and I can use this difference in water heights to calculate how much pressure, how much force the gas particles in here are exerting. And so using a U-tube, I can measure pressure as the difference between